Assalamualaikum warahmatullahi wabarakatuh. My name is Mohd bin Muhammad Sufian, and today I'll be presenting about smart adjustable headrest for cerebral palsy children using 3D printer. Right. So first of all, let's do the introduction. So what is a headrest? Headrest is a type device that was used to provide head and neck support for the user. And obviously, for this case, I'll be focusing on the cerebral palsy. So the main problem for cerebral palsy patient is they cannot erect their head straight, and they cannot control their head movement as the muscle tone is in the state of hypotonia. So what is hypotonia? Hypotonia defines as the low muscle tone, and also this means that the headrest will prevent their head from swinging on the frontal and digital plane. Sagittal plane. So frontal plane is basically the forward and backward plane, and then sagittal is side by side plane. Okay, so the children that were diagnosed with total body involvement cerebral palsy, they have zero postural control, and as you can see from these beautiful children over here, so they depend on their life for using the wheelchair, and also the headrest will keep their head from moving. Okay, so from what I found is that as of today, they were only manually adjustable headrest, and this means that there are lack of smart adjustable headrest in the market today. Alright, so we move on. So the objective is to design smart adjustable headrest for cerebral palsy children and able to fabricate the smart adjustable headrest for cerebral palsy children using 3D printer and integrate it with electronic mechanisms. So for this methodology, there are three phases that I did, which is first design process, and then I do the analysis, and also the fabrication lastly. Okay, so first of all, first phase is design process. So first I establish the problem statement, and then I do the literature review, I do some readings on it. I do a lot of readings on it, and then I develop conceptual design, and after that, lastly I do the embodiment design. So I established the problem statement. So firstly is the dialogue of smart adjustable headrest in terms of market availability and research and development towards it. And also there are only manually adjustable headrests in the market right now, which uh, which makes it harder for the patient to adjust it because it is manual, right? So, and then I move on to the literature review. So I review the past and current research towards the development of the headrest and is important to total body involvement cerebral palsy children. So total body involvement cerebral palsy children is basically a children or a person that is zero control over, they have a little to zero control over their body, and all of their body is having a spastic condition. And I do pattern review to find the best mechanism for the headrest to work. And so the pattern review is because there are a lot of mechanisms to choose from, and I am choosing the simpler one because it is much simpler to assemble and much simpler to do maintenance. And also the various type of material were compared to find the best materials to use. As you know, there are a lot of materials that can be used for the 3D printing, which is the famous one with PLA, ABS, PETGs, nylon, ASA, etc. And then I want to find the best fabrication method in the case of additive manufacturing, which includes powder bed fusion, material extrusion, material jetting, etc. So material extrusion is basically an FEM. And then I've developed the conceptual design. So how do I develop the conceptual design? Firstly, I establish the PDS, which will be the guide for all of the design after this. So for this conceptual drawing, I've developed 4 conceptual drawings based on the PDS. So concept 1, 2, 3, and 4. There are 4 concepts. So and then I weighted in the per chart. So as you can see, the third concept is chosen because it has the most heaviest weight. But as you can see after this, I only develop the draw the cat based on third concept in the proposal stage, which is the first version. But we'll see after this. Okay. So and then I do the embodiment design in EasyEDA and SolidWorks 2018. So the function of EasyEDA is so that I can draw my electronic circuit inside of it. And for the SolidWorks 2018, it is a software to draw CAD drawing, CAD modeling, CAE, FEA, simulation. There are so many functions in this software. Right. Okay, this is what I meant when I developed only the first version based on the third concept. So why? This is because during the CAD drawing, I found that there are a lot of disadvantages by using this version, and that's why I developed version 2 and version 3. So the main differences between the version 1 and 2 and version 3 is that their weight distribution and the way this thing is the lead screw are mounted. So when the lead screw are mounted on the middle, like the version 3 and 4th, I have actually 4 versions. The final version, the 4th version is the final version. So is that the way the weight is distributed. So the version 1 and 2, it is not exactly 50-50 distribution, right center and right and left, compared to version 3. Version 3 is quite stable. The weight distribution is actually 50-50, around 50-50, but it is stable. It does not topple. It does not topple on side by side. Okay. So and then so the 3rd version and the 4th version is actually quite the same. The differences is in the design of the headrest. So why I chose this type of headrest is because I found that during the fabrication, the 3rd version is very heavy. It weighs at 1 kilogram, and this proves that the worm motor the worm motor can carry, but the way the track that is inside this thing cannot handle it. So it only can move on one direction. It cannot move downward. It cannot move outward. Right. So and then this is the electronic circuit they have developed. So as you can see, there are 2 linear actuator, 1 DC motor, all of them connected to the MDD3A. And then this is the maker nano, and this is actually the IR, which is the IR is used to control all of the movement, IR remote. Okay. So and then I move on to I do the analysis of it. So I analyze the different materials for the headrest. So as I have stated earlier, there are a lot of materials to be used for this FDM, and then also I analyze the most suitable 3D printing orientation to use. And then for the different materials for the headrest, so I've chosen 3 because these 3 is the most popular one. So I've used PLA, ABS, and also PETG. And then for all of the pre-analysis, the load is 50 Newton, the type of mesh, solid mesh, and then etc. Alright, and then as you can see, this is the meshing body. So so the meshing body is 20,000 something, and then this is the direction of force. So the direction of force is 50 Newton. So the purple one is the direction of the force. As you can see, this is the force direction, and then the boundary condition is the green arrow. So actually this part is connected to the linear actuator by using a screw. This is actually, for information, is fixed support. Alright. And then for the analysis, I do the analysis on the 3D printed orientation in the slicer. Okay. So for then the last phase is the fabrication. So for the 3D printing sequences, firstly I save the CAD file as .stl or 3mf, and then I load the file in slicing software, and then I edit the print settings in slicer and produce the G code. Then after that I load the G code in 3D printer and I print. And then after that, yeah, you've got the part. Okay. So for this, for the slicing software, I've chosen 2, which is Precise Slicer and Ultimaker Cura. So why I choose these 2? Because these 2 has some of the features that the other one doesn't have. So example, in Precise Slicer, I can actually set in the slicer where I want the layer to pause, compared to the Ultimaker Cura, where it is much harder to do so. Okay. And then for the print settings, there are 2 nozzles that we use. This is 0.4 and 0.8. Why there are 2 is because 0.8 is used to print larger things that doesn't need much details, and 0.4 is used for something that needs detail. So because 0.8 nozzle is much faster compared to 0.8 in terms of printing speed. And then this is the headrest in Ultimaker Cura. So as you can see, it took 17 hours and 37 minutes, and the weight is 155 grams. Okay. And then after that, I load the G code in 3D printer and I hit print. So this is I'm using Octoprint. So why Octoprint? Why I'm using Octoprint is because it is much easier for me. It is connected over Wi-Fi, so I can transfer the G code into the printer wirelessly. Okay, and then this is the printing in action. Okay. And then this is all of the parts that I've fabricated, and this is the result. So as you can see, this is the headrest, this is the housing, this is the clamp. I also repeated the clamp. because it is hard to find aluminium clamp that is appropriate. Okay, so let's see the video demonstration. So as you can see, my head actually fits the headrest, but yeah, I'm pretty sure the children's because my head is quite big, right? So this is the internal of smart adjustable headrest. So as you can see, there are 1 lead screw, 2 linear actuator, MDD motor, 3 motor driver, shaft coupling, mechanano, and step down voltage regulator. There is actually a worm motor inside, which is that is connected to the shaft coupling, and also there is connected to lead screw. It is to use for vertical movement, and then the linear actuator is for horizontal movement. Alright, so for so how I want to find the effect of different materials for the adjustable headrest. So I've chosen the static analysis to carry out for this study, and then all the materials are compared to find the lowest deformation. So the material that are compared is PLA, PGG, and ABS, and I found that PLA has the lowest deformation, and also the material that have been chosen for this study is PLA and PETG, and PETG is technically weaker, but it can sustain higher temperature with temperature at 80 degrees C, while PLA is around 50 to 80 degrees C. So this means that PETG can sustain much higher temperature better compared to PLA. Okay, so this is the deformation of it. So as you can see, PLA at 11.69, then PETG at 19.57, ABS at 19.65. So as you can see, the green one indicates that PLA is the lowest in terms of deformation. And also for the stress is essentially the same. PLA at 3.51, PTG at 3.39, ABS at 3.41. Okay. So based on this graph, as you can see, the relationship between stress and deformation is actually inversely proportional. So PLA has the lowest deformation, but it has the highest stress compared to the PTG and ABS, which is essentially almost the same but not the same. So this is the deformation. So as you can see, it move up, upward when it is applied load and does not fail. Right. So and then we choose the different 3D printing orientation. So 3D printing orientation is very important as much as the infill of the component. And then through my extensive reading, I found that the most suitable orientation is the direction of the force needs to be perpendicular to the printing direction. The correct orientation also will significantly reduce the amount of print time, as I will show it after this. So you can see from this picture over here, so this is the movement of the print head, which is the printing movement is moving upward. So this is the layer, and we can see the bonding layer normal to parts is strong. So compared to this one, which is this is the direction of the printing, and this is the compression, and it will obviously it will shear. It is really weak. Okay, so the different 3D printing orientation, so it is significantly reducing in time. So as you can see, there are 3 different orientations. So the first one took 30 hours and 45 minutes, and the second one took 20 hours 38 minutes, and the longest one took 79 hours 44 minutes. This is because this will print a lot of support material, and yeah, it will print a lot of support material compared to these two. But this one also significantly prints amount of support material compared to this one. So I've chosen this one because it is much shorter in terms of duration, and also it uses and it also is the strongest in terms of the orientation. Okay, let's move on. Right, so for the recommendation, I recommend implementing automatic movement according to the user's head position. and then integrating the device with the Internet of Things, IoT. So what does it mean by integrating with IoT? So imagine a person that is sick, and then the person is using the headrest. The headrest has a temperature sensor that will detect the temperature. If the temperature is abnormal, and then it will, because it is connected to the internet, and then it will send the data to the doctor's office, and then the doctor will notify that this person is having a fever or maybe something much worse than that. So an early treatment can be due to save the patient's life, the people's life. Therefore, as a conclusion, the objective of this study has been achieved, which is to design a smart adjustable headrest for cerebral palsy children and be able to fabricate it using a 3D printer and integrate it with electronic mechanism. So the component can sustain the load that were designed for it based on their analysis. Right, so thank you for listening. So as usual, if you have any inquiries, if you have any question, you can contact me at my email at imransufian@gmail.com or my phone number at 013 2222 639. Thank you for listening. Bye bye. Have a good day.